Yeah, good morning, guys. So, tell me, have you started working on yesterday's longer assignment? You have started. Very good. So, done also. Very good, Prashant. Excellent. So, anyone wants to ask any question regarding that before I start today's topics? Very good, Sumi. Almost done. Yeah, excellent. So, if there are any questions, please ask. Otherwise, we'll start with our revision and enter threads. Okay, so since there are no questions, you can ask me even later in the lab session. So what we are going to do is I have one pending topic which I have not taken earlier regarding method overriding and exception handling. So that we will do. Can we use CK? CK is what? Composite primary key you are saying? Are you talking about composite primary key, Prashant? Yes, you can. Answer is yes. So we are doing method overriding and exception handling. So that part I will take. And then for the rest of the day, I mean the whole day today, tomorrow, we are going to spend in threads. So before that, let's do a quick recap of serialization so that you can build. I'm going to today combine. Today, tomorrow, I don't know, but time permitting, we are going to now combine collection IO plus threads also. So here. So for that, your serialization and all that has to be clear. So what is serialization? It's a conversion of the state of the object into binary stream. And anytime anyone asks you what is included in the state of the object, it is data members, which are non-static and non-transient. So you have seen yesterday, transient members are skipped from serialization, and static members are also never added into that binary stream. So that is your serialization. But if you go a little detail, you will see that it is not only the state of the object, there is some additional information. So here the second question, what is exactly converted or what exactly exists? What is a part of a binary stream? Definitely the state of object. But in addition to that, there is a metadata information. So guys, if you read my serialization in details readme, you will know that towards the end somewhere I have discussed in detail the format of that binary stream. So it starts with magic numbers, which are specific to Java version, serialization format number, then the class description starts. So fully qualified class name, serial version unique ID. So yesterday we spent some time on serial version unique ID. So does anyone want to tell me, serial version unique ID, will it be per object or will it be created per class? Per object or per class? You understood my question? Serial version unique ID, is it going to be created on per instance basis or per class? Of course it is per class, because if you remember, it is static and static members are loaded per at the class level. So it will be generated by the compiler taking the help of serial version tool. Yeah, I've shown you also yesterday the generated serial version unique ID, and that is computed upon entire class structure. So all this information plus state of the object is converted into binary. So now start answering simple questions. What is the name of the class which performs serialization? Or you can tell me, which is the serializer class? Easy questions. If you have done it, revision, you should be able to tell. Of course, answer is right, object output stream. Which are the main interfaces it implements? Which are the interfaces your object output stream class implements? Wrong answer. Object output stream class is not implementing serializability. Serializability has to be implemented by the Java objects whose state has to be converted. Yes, the two interfaces. There others are also there, such as clonable and all. I'm not talking about that. So data output and object output. right? So what are the methods? Can you tell me some 2-3 methods which we have used yesterday from data output interface? Couple of methods from data output interface, please. Yes, all writing primitive types plus strings. So write int, write boolean, write double, and write UTF also. Read int is wrong answer, Shubham. I'm talking about writing. How can you say read it? Next one. When you talk object output brings in the capability of serialization, and which is the main method we have used from that object output is, don't say write object and read object consumer. It is, we are talking about only writing part, object output we are talking about. So write object. Okay. If you recall the constructor, object output stream, it is taking any a binary output stream constructor. So can I replace this by buffered output stream? Can I substitute it by buffered output stream? Yes. File output stream, socket output stream, piped output stream, all answers are yes. So what is the job of your object output stream? A simple conversion. The conversion from object to binary. And once you have got that converted binary stream, after that, yes, Shubham, after that, it is up to the programmer to either route it to your pipe or to file or to socket, that is, or to buffer, that is up to you. So this argument is nothing but destination binary output stream. And like I was asking you, these are the methods which are borrowed. Borrowed is inherited from data output interface. And this is one of the methods. There are additional methods, but again, I'm sticking to your contents, syllabus. So that is write object. Everyone knows if you want to write this serialized binary stream in a binary file, what is the corresponding chain of resources? Object Java application has to sit next to the converter stream. Buffering is optional totally, but here I've just written it to show you all the 3 examples. So this is your filtering is equal to converter stream. This is your buffered output stream. This is your node stream wrapping the device. But like I said, in most of the cases, you don't require buffering. So tell me, what will be the corresponding code here? That is the one of the easiest thing in code. What is it? Java.io, new object output stream, new file output stream, and here you can supply the name of the file and like this. Everyone gets it? Yes, you are right, guys. Now, next question. You remember yesterday we were working on map of products. So when you wrote, so as an example, suppose I write in my IO utils out.write object. And suppose I write a hash map or products. And what is products? Products is nothing but a, I'll give you the data type of, yesterday you have done this. Products is nothing but the hash map of the type integer, comma, product. Okay. So now answer this. When product class had not implemented serializable interface, and when we tried to say out.write object, in that case, what happened? Did serialization continue? Did serialization work or did it fail? Exception was raised. So which was the exception which you saw? The fully qualified name is, from the package java.io, and the name of the exception is not serializable exception. Okay. So here you have to tell me why. So when I say why, who is detecting this? JVM. So what is the rule? The rule is JVM checks the serializability of the entire object graph. When I say object graph, it starts with a node of hash map. Then hash map has a key. Hash map has a value. Product, then like how it proceeds. So why it is? Serialization is all or nothing, right? So you cannot do it this way, that if you have suppose 20 nodes in that object graph and something like 15 has serializable, 5 or not, entire serialization fails. So JVM checks the serializability of the entire object graph. So now what it will start? It will start with hash map. Tell me, is hash map serializable or not? It's a Boolean question. Hash map is serializable, so passes it. Then it comes to the key type. Is integer class this thing serializable? Yes. But when it comes to our when it came to our product class was not serializable. So anytime JVM comes across any object which has not implemented, which interface? What is the heart of entire serialization and deserialization? Everyone knows the answer. Serializable interface. So whenever JVM comes across this, which has not implemented serializable interface, here JVM aborts the process, aborts the serialization, and throws the exception. So everyone is clear. Whatever are the objects, whatever you have supplied as the argument, entire object graph has to implement serializable interface. Otherwise the entire process aborts. So that is about your serialization. So now opposite thing, if you just convert object into binary, you know that the process is only halfway. So now you have to do the reverse conversion. So what is deserialization? Deserialization is even more impressive process. Why we are saying it is more impressive. See guys, JVM you are giving only couple of bits as in binary data, some metadata information and some classes. And JVM is going to build the entire. There is nothing in the heap, nothing in the method area. JVM is going to do the whole process. So the entire reconstruction of entire object graph from that incoming binary stream. So when you say the binary stream, can it be coming from file? Very much yes. Can it be coming from pipe? Yes. Can it be coming from socket input stream? Yes. Or can it be coming from buffer as in buffered input stream? Yes again. So your deserializer does not care where is that data source. It can be any binary stream. It will just take it will just try to convert it into, try to reconstruct. So let me ask you, yesterday I've taken a lot of time to explain all these points. I hope you have slept over it, you have understood it, you have revised it. So tell me, what are the prerequisites of deserialization? When I say prerequisites of deserialization, what is it which your JVM will require for the reconstruction of entire entire object graph? So the formal answer is state, behavior, both or neither. What is it will require? Answer is it will require both. Don't say state. If you say state, again you are wrong. That means you are not revised correctly. It is going to require both. So from where it is going to get the state information? From where it is going to get this state information? Binary, don't just say binary file. Yes, dot class is wrong answer. The data members are not in dot class file. The binary file is the correct answer. Where it is going to get the metadata information, that these are the classes to be loaded, these are the names of the classes to be loaded, again binary file. And what else you'll require? So you open your products.acr. Why don't I open? Here. So if you just open, because whatever I'm saying should make sense, not just like sound theoretical somewhere. So suppose you open any of that binary file, this metadata information, that is which class has to be loaded, is all written here. That is called as a class description. But actual dot class file, actual hashmap.class, is it part of this binary stream? Is it part of this binary file? Absolutely not. So that is when the second prerequisite comes in. So second, first you say, so you have to supply, you as a deployer, you as a developer, basically, you have to share the dot class files for Java built-in types or UDTs. Asking you a question. Of course, UDTs. Java built-in types are part of JRE. They are already available. So you have to provide the .class files for UDTs. It could be a customer placing an order. It could be custom exceptions. It could be category. It could be product, etc. And that has to be added in the runtime class path. So what are these user-defined types representing? Behavior part. And if the classes, if you have forgotten to do this, which is the exception we got during deserialization? When we had not added these classes, which is the exception you observed? Class not found exception. So java.lang. Class not found exception. Exception was thrown by the JVM's class loader during the loading process. So let us say, okay, sorry, I've written later. Okay, I'll just take this point. Which is the best way of sharing the dependencies if you're working in a distributed environment? Should you create the separate .class file or should you bundle it? Answer is a bundle. So which is the best way to create this separately, creating a jar file? And how can you create a jar file? Your IDE has the option. You remember I have shown you the IDE option. You just say right click, whatever you want to share. Simply say right click and export and do the thing. But if you say no, I don't want to use IDE. I want to use my command line tools. So you know I have shown you jar TVF, T for tabulating. So there is an option called a jar CVF. C for create, V for verbose, F for file name. So this will create the jar file. So you can supply the something like my dependencies. I mean, just giving something .jar, and you can supply the folder. Suppose I want to it on all the things from com.app.core, whatever. So you can supply the name of the it's not a package actually. You can say dot. You know, dot means whatever is under the current folder, you can supply that. So you can give the path of wherever your classes are. So I have not shown you this option because we don't require we are sitting in ID. But if anyone asks you, can you create the jar from the command line tools? 100% yes. Okay. So now I'm asking, suppose you have supplied the dependencies, so you'll not get a class not found exception. But if the version of the class which you had used during serialization, and then you made some changes, and after that you gave it to the deserializer, which will this mismatch will be caught with one long unique number, which is serial version unique ID. So tell me, who computes this serial version unique ID? Who calculates it? Serial version tool. Java compiler, but using serial version tool. Absolutely. And that is stamped. Oh, okay, let me ask you. Is this serial version unique ID added in a binary file? The .acr file, does it have it? 100% yes. So this binary stream is sent to the deserializer. Tell me, what will deserializer do? You understood my question? I said this is written in, this is given in a binary file. What will deserializer do? It will compare. So for comparison, you require two things. So one is the incoming, that one is the serial version unique ID, which is in the binary file. How will it compute the other one, the local serial version unique ID? Are you understanding my question? One is coming, one is read from the file. Where's the other one? Yes. So here from the jar, at the time of loading the classes, it will compute the product. Suppose I take an example of yesterday. So product.class, while it is getting loaded, it will compute the serial version unique ID. And in case of a mismatch, will it continue with a deserialization or will it throw you an exception? Everything we have seen, I'm just recapping it. Of course, it will throw you an exception, and that is your java.lang.invalid class exception. There is another trigger also for invalid class exception. I've written it in the README. You can read it later. Okay. So the point I'm trying to say is for the JVM to create the entire object graph, recreate the entire object graph or recreate a single object if you are given, you have to provide the .scr file, which contains the metadata and state, and plus you have to also supply the user-defined types. So once you have done all that, tell me, which is the class which is used for deserialization? It's an easy one, object input stream. So that is the deserializer which is used. What is the constructor of object input stream? What is the input argument it takes? Anyone? Input stream is a correct answer. Object is a wrong answer. Here it takes the any binary input stream. So can I substitute it by file input stream, piped input stream, socket input stream, byte array input stream? That is your memory stream. Answer is yes. Deserializer is just a converter. It tells you that give me a binary stream from anywhere. I don't care. I'll do the job of my deserialization, reverse conversion. And which are the interfaces it maintains? It implements. It is exactly opposite. Data input and object input. And the methods you already know. All read methods, all write methods earlier discussed. Replace it by read. So these are for reading primitive types and strings. And this is where actual deserialization happens. So now you will understand. In case you have not supplied the UDTs, this method might throw you class not found exception. If there is a mismatch, version mismatch between serial version unique ID, it might throw you invalid class exception. And if there is a genuine error while reading the data from the file, then it might throw you file or pipe or socket, whatever, it will throw you IO exception. So these are this is what is about deserialization. So once you have understood this, creating the stream is so easy. So you have got that binary file, that is some products.scr, or yesterday you were doing books example. So books.scr library, I don't know what .scr file, some .scr file. So that you are reading using file input stream. This has the pure binary stream read by the deserializer, read by the Java application. So how do you convert it into code? One of the easiest things. Object input stream n is equal to all auto-closable, new object input stream, new file input stream, and either you can give the validated file class instance. You remember we validate whether it is existing, whether it has a read permission, file and all that, or you can directly supply the file name. And once you say in dot read object, if you say in dot read object, at this point, deserialization is happening. Right? So tell me the last question. What is the return type of in dot read object? Yes, somebody had written this object, but we know that it is the map of products. Suppose, for example, in your case, it will be map of books, right? That has gone in. So can you perform the downcasting here to get the actual type? Answer is yes. So you can supply. So for example, in your case, it is a book map. So string title, comma book. So you can easily do the downcasting and return this to the caller. Are we understanding it completely? The serialization and deserialization part? Okay. So having said this, you might be thinking that this is the way to do things. Does it is problem free and all that? Absolutely not. Sorry. So there are lot of problems. Problems mean the sense disadvantages, limitations of serialization approach. That is why it is not 100% go-to approach. So let me show you. If anyone has read my README, I've already mentioned it here. So if you look for limitations or something, so here, the first limitation is, before I read this, I'll give you a requirement. Suppose you're going to learn .NET also right after this. So suppose you have got a .NET server. I mean, the server side application written in ASP.NET or something, different technology. And that has sent you a .NET object to Java technology, will you be able to, will you be able to deserialize the .NET object, C# object, basically using deserialization? Answer is absolutely not. Meaning, is it a Java specific 100% Java technology solution, or is it a cross technology solution? Answer is 100% or limited to Java technology. Means what? If you write a server-side application in Java and client-side application also in Java, then you can use serialization, deserialization to do the object exchange, not otherwise. So if I want to write this cross-technology solution, what is it we use, guys? If I want to do the cross-technology, yes. So, okay, JSON is the data format, but the answer is web services. Web services is the go-to solution. So earlier, web services were created using SOAP-based APIs or other SOAP, Simple Object Access Protocol. But today it is all REST-based, REST API-based, which is what we will do at towards the end of your advanced Java. So this is not like interoperable solution. This is only Java. Next disadvantage or limitation is, if you are saying, if you see, client always tells you that these are the services I want, okay, and accordingly you develop the solution. So if there is a always changing, if your class format, you know, the class, for example, product class, every now and then, if it is going to change, every time you have to recreate the jar, share it with a deserializer and all that, so it becomes difficult. Yesterday, if you remember, I purposefully showed you that error. We had made some date transient, but purposefully we did not update the jar and we landed into invalid class exception. So the whole point is, this approach becomes really difficult in case of changing class format, because you definitely forget to, you know, sync it up with the deserializer end, and the whole process becomes little hard. But the worst disadvantage is, these are okay. So first and third are the real limitations. The worst disadvantage is it a secure solution or is it a non-secure solution? This thing, what is it called? Serialization, completely non-secure. Why? Because, see guys, let me see this. This format, I have not written an actual bit by bit or byte by byte format, but with every Java version coming up, now it is a 6-monthly release, you know that. So suppose let's say JDK 18, JDK 17, with every Java version, they publish 2 documents. One is JLS and one is JVM specs. JLS is Java language specification and one is JVM specification. So the point is, in that JLS document, there in one of the appendix, they give you the detailed file format of that serialization. I mean, of that by serialized binary stream. So any malicious user, any hacker can simply take your, if you're sending it across the network, the .scr file, anyone can simply hack this file or get this file, write a binary walker, I mean binary utility to walk the data, to read the data, and can get the information, private information. So because of these limitations, I mean, that is why it is a security hole. That is why it is a security leak. Okay, so 100% times this is not a go-to solution. But in cases where you have the, like for example, HTTPS protocol, you know, HTTP over SSL. So if you are having it, then it becomes very difficult. Nobody said yes or no. HTTP over secure socket layer. Okay, because that is what we'll be using later. Anyway, so if you are exchanging the data over HTTPS, then such security leaks are plugged. So this is what is you should keep in mind, that whenever you are suggesting a solution, it has security issues. So this was the complete revision of serialization and deserialization. So now, before entering threads, I just want to take a very small pending topic, because once I enter threads, I don't want to keep any loose ends anywhere. We can dedicate the total time there. So let me take you back a long time back. when we were talking about method overriding and exception handling. So let me see. There are specific rules during for method overriding. So let me start asking you, where will be the overriding form of the method? Superclass or subclass? Easy questions. Subclass. So what it should have? Can it have same method name or different method name? What about the return type? Same or subtype? Guys, return type, where is your memory? Covariance, we have done it. It can be either the same or it can be the subtype of the superclasses return type, which is we call it as a covariant return type. What about method arguments? What about method signature? The method signature has to be the same. So what about the scope? Can it have the narrow, can it restrict, can the overriding form of the method restrict the scope? No, it should be same or wider. So all these I had already explained with examples, but I never got time to show you the last one. I told you that we will do it in exception handling and we never got time around that. So read this carefully. Overriding form of the method, that is the subclass version, it cannot throw any new. New means the ones which were not defined in the superclass or any broader checked exceptions. I hope you remember checked. The ones which do not have the runtime exception class as the super type are the checked exceptions. So overriding form of the method cannot throw any new or broader checked exception. So let me ask you, when I say broader related to inheritance, what will be broader while going up the hierarchy or while going down the hierarchy? Up or down? Of course, going up. Because you know, the inheritance, when you walk down the tree, it is generalization to specialization to the more specific form. So when you are climbing up the hierarchy, of course, broader means climbing up. So this is the only statement you have to remember. Let me send you this. I can send you the whole. Shall I send you the whole sequence? Give me a second. I'll send you the whole sequence. Again, there's no guarantee that I'll finish it right today, but yeah, you can still have it. So this is what I plan. So just download this so that you'll have this statement in front of you. Overriding form. Kunal, it is an off-track question. So now just keep it aside because I've already started some other topic. So leave it aside and ask me just before we stop for a break. If you did not understand my statement at all. So here, overriding form of the method. This is the statement you look for. Cannot throw any new or broader checked exceptions. So I've given you my statement. Why? Because then the code will break. Then the one who is using your APIs will break. So now I'm just asking you what will happen. These are the very popular questions, exam questions or whatever questions. Okay, so question is what will happen? All I'm asking you is compiler error or no error that time. Okay, so start reading this. Package P1, class A, show method, SOP1. I mean system.out.println. So there is no error here. I'm not asking you this. I'm saying now I have written a subclass. So here is the question. Compile time error or no error? I hope you got that sequence and you have that statement now. You just have to tell me compile time error. File is not received. Have you received the file, guys? Kanad is saying file is not received. Yeah, so send him, please. Send him again. He's not received it. Okay, so here, tell me. Tell me, compile time error or no error? Quickly. Of course, compile time error. What is the rule? Overriding form. This is your overriding of form of the method. Can it add a new checked exception? Interrupted exception is a checked exception. Check the hierarchy. It doesn't have runtime. So how can you introduce? Okay. So of course you will have your Java C error. And why? Because it's a new checked exception. Once you know the rule, it becomes so easy to answer. Okay. So this is it. Now, so Now ignore this. Or you can continue to look at this, but now look at it and tell me, compile time error or no error? Easy question. 100% no error. Why? This is also newly added exception, but why there is no error? You're absolutely right. It is no error. Where is that? Here there is no error since it is a unchecked exception, and everyone knows compiler does not force the handling of the unchecked exception. And you all know that this is nothing but upcasting and runtime polymorphism, calling the Beats show. That's not the point. Okay, so this was the first of the many. Now follow the next example. Now the separate example. Example 2, second code sample. So take a look at this. This is your base class. That's why I've shared the code, shared the sequence with you. And here, this is your subclass. Tell me. The question is here. Compile time error or no error? All are wrong. What is the rule? Guys, you just have to remember the one-liner rule. It cannot throw any new or broader checked exception. So here, the superclass version is throwing a checked exception. This fellow seems to be handling it. Is it introducing any new or broader checked exception? Absolutely not. So here, you can always decide to handle the exception using try-catch block. So 100% no error. Got me? Understood the this thing explanation? You will have a compile time error if the overriding form is adding a new checked exception or adding a broader checked exception. So 0 error here. Take a third sample. So your superclass method is including in the throws class IO exception. Subclass is including in the throws class file not found exception. Same question. Compile time error or no error? Your answer is correct. Tell me why. Is it just a fluke, coincidence, or you have really understood it? Wrong answer. Okay. I've still not got a good answer. I mean, convincing. I have not got something which is, yeah, what do you mean by sub, Komal? Not broader. Okay, subtype. So give me a proper answer which you can sell in interviews. File not found exception extends from IO exception. IO exception is the superclass and file not found exception is the subclass. So listen to the question correctly, guys. So suppose you have written a tester and tester is using this A's method. Tester will anyway have a try-catch block for IO. So if I have got catch IO exception, can it also catch its subtype? Of course, yes. Are you understanding it? That is why compiler will never issue the error if your overriding form is throwing the narrower form of a checked exception. So here, no error, as you said rightly, since what? File not found exception extends from your IO exception. Okay, so narrowing the exception is always okay. Why? Because your handler means whoever is using this has already added a catch IO exception, which can definitely catch a subtype. So all good. The last combination, and we are ready to enter threads. So this is your superclass method. This is your subclass 1. Compile time error or no error? I hope everyone got it by now. 100% compile time error here. So the same logic here, IO exception. Suppose the handler, the tester has written catch IO exception. So that catch block, can it catch the exception? Are we going broader or are we going narrower? We are going broader. So Java C error, since exception is a superclass. So of IO exception, in short, broader and checked exception, of course. So that is why compiler throws you out. So these are the popular questions asked, I mean, favorite questions and all that. So if anyone has not understood any of the cases, I'll just suggest take it, copy this to the ID, SOP and all, you change it to proper system.out.println and convince yourself. Okay, so this is what I wanted to cover just before entering threads. So now, finally, coming to the last important topic of this thing, what do you say, core Java. There are some loose, I mean, there's like cloning, reflection and all that, but I'll take it in between. So I have to complete threads and then only I can take you to advanced Java. So let us start with the last and important topic of core Java. Two important topics of entire core Java are, one is that collection framework and one is threads. Okay, so of course we don't go to threads in that detail, but yes, we'll still understand. So start with the basic most questions and then I'll lead you to the advanced way all the time, all the way. So start with the simple one. What is multitasking? When you say we are doing multitasking, no, see, it is a very general slang. So whenever, okay, you tell me, what is multitasking? Simple question. Yes, executing or performing multiple tasks concurrently is multitasking. Everyone knows that, correct? So here, our operating systems, any operating system you take today, is it multitasking based or single tasking based? Of course, it is multitasking. In the sense, here the Zoom process is running. My notepad is running. This thing, whatever, Explorer, so many processes, so many applications are running parallelly. So 100% it is a multitasking based operating system. So simple question, why we have multitasking? Why we do multitasking? Or why our operating systems are multitasking based? Tell me. Everything has a reason. Yes, absolutely correct. Only CPU? Yes, efficiency, but proper this. To increase the best utilization or not flexibility to the user, I can't buy that. Yes, to increase the effective utilization of CPU processor as well as the resources. Which resources I'm talking about? It could be a socket, it could be a database, it could be files. So whatever resources, of course, processor is also one of the resource. So maximum efficiency. So for example, suppose one process means one application which is running on the top of the operating system. Suppose that process is blocked. Why it is blocked? Maybe it is waiting for some input. So if one task is blocked, is it going to affect other ready to run tasks, or is it not going to affect? Of course, it is not going to affect. So that is the heart of multitasking. Any blocking task will not affect the execution of other concurrent runnable tasks. Okay, so that is why we have multitasking based operating systems. But that is the time we talk about processes. So now I'll first show you the difference between process and a thread. You must be already knowing it from your OS concepts, so it could be just a revision. And then the most important thing is thread state transitions. And then we'll parallelly start with threads API. And then we will solve so many objectives in threads. Okay, so let me start showing you things. What I wanted to show was process versus threads. Okay, so take a look at the basic difference between processes and threads. So first, everything starts, whether it is a process-based process-based or thread-based, it is a multitasking situation where we plan to execute multiple tasks. Okay, so why is already clear. To increase the effective utilization, to optimize the usages of resources, including processor as well as IO resource or any resource. And the main thing is, here you can ensure The moment you are performing multiple tasks, blocking of a particular task will never affect other runnable tasks. Okay, so that is the key of your multitasking based ideas. So now this is your process based, this is your thread based. So first look at process based multitasking, which you already know from your OS concepts. So when you say process based multitasking, the entire unit which is swapped in and swapped out is the process. But before I say this, let me just talk to you. Let me ask you a basic question just to check your clarity. Suppose, today we have processors, cores, and multiple things. But suppose you have only single CPU and single core, maybe earlier days. Can you still run multiple tasks on it? It's a yes or no question. If you have a single processor, I'm not saying exactly at the same time, guys, but can you run the tasks parallelly? 100% yes. What you're saying, no. 100% yes. So I was worried of that. Don't you know the concept of a scheduler? Yes or no? Do you know the scheduler? So scheduler sits between your processor and the applications processes. So scheduler is the one who is going to be in charge of your job scheduling or task scheduling, to be precise, which is the task which will be given, which will be chosen by the scheduler, highest priority or lowest priority, obviously, highest priority task. And then that task, that process is given the CPU time, processor time. And then whenever there are different types of schedulers, I'll come to that. And then this is how the scheduler can manage, even with single CPU, multiple tasks. So that is possible. So the next question. There are two different types of, mainly, there are multiple types of schedulers, but two major schedulers. One is the round robin, which is time slice based scheduler, and one is preemption based, preemptive scheduler. So let me ask you about this thing, time slice based, round robin. So what happens in the time slice based scheduler? Every task is given a specific time slice. And so one task starts running. The highest priority task is chosen by the scheduler. It starts executing. It gets the CPU time. And what will happen once the time slice is over? Simple question. The task, it is swapped out. Context switching. Yes, context switching takes place. The currently running task is swapped out to runnable, ready to run kind of a pool. And the next highest priority task is, don't use the word preemption. There's no preemption and all that. So wrong terms, that is. So the next highest priority task is taken. There's no preemption, there's no overriding. But now I'm talking about preemptive multitasking. So anytime lower priority task is running and higher priority task becomes ready to run, and you are using preemptive based scheduling, what will happen? Starvation is such a wrong answer. The lower priority task, this is not yet starvation, will be swapped out, and the higher priority task will be swapped in. So here, basically, then I can talk about this. So there is a possibility of a process starvation, but that we are not yet entering. So the point I'm trying to make is the swapping unit in that context switching is the entire process. Now come to the Java part of it. As a Java developer, using Java API or your JVM, can they control? Can they, control is the one. Can they affect the process level multitasking? Absolutely not. Why it is not possible? Because Java itself, JVM itself is running as one of the processes on the top of your operating systems. So how can one process control other? So that is out of question. And just now we were talking about context switching. So tell me, when you have process level context switching, process based context switching, will it be fast or will it be slow? 100% it will be heavyweight, as in slow. Why? Because When one process is swapped out, the entire information which is required for bringing in that process back is lost. In short, will multiple processes, will they share the address space or do they live in separate address space? I said multiple processes, do they share the address space or do they live in separate address space? Of course, the answer is they don't have anything shared. So that is why that is why the context switching is extremely going to be heavyweight, as in time consuming. So what are we going to do? We are not going to, we cannot. It's not like we are not going to, we cannot do the process-based multitasking. But can we do little bit? Can we partially control the something like thread-based multitasking? Answer is yes. So tell me, what is a thread? I've already written here. A single process, or okay, let me say it properly. It is a smallest concurrent runnable independent task, independent part of the process. A subpart of the process is a thread. So here we are talking about, yeah, individual smallest execution unit which can execute independently, concurrently. That is what it is. So thread levels give you a better control. So a single process can be subdivided further into parallel concurrent runnable tasks. And this individual task can be identified by a thread, or that is nothing, that subpart of the process is a thread. So when we enter thread-based multitasking, can your JVM, can your Java API control it fully? Absolutely not. Who is ultimately going to control the scheduling or the thread-based multitasking? The native operating system. Underlying operating system, wherever you are running it, be Windows or Mac or whatever, that is going to control it. But can you at least control it partially? Answer is yes. And when I show you the thread state transition diagram, I'll tell you that these are the transitions you can control. These are the transitions beyond your control. And now the context switching. So tell me, process-based compared to process-based context switching, will this be faster, lightweight? 100% yes. Why? Because all the threads belonging to the same process, do they run in separate address space or do they share the common address space? 100% they share the common address space. So guys, it is time to recall. On the second day or third day, I don't remember, I have shown you partially JVM architecture, mainly JVM memory areas. You remember the 5 memory areas: stack, heap, method area, and program counter registers, as well as native stack. So forget the last two. You tell me, if you create multiple threads from a single Java process, will they end up sharing heap and a method area? Is heap and method area shared resource or not? People are saying not. Come on, Abhijit, you have to look at that this JVM architecture. Of course, they will be sharing not method area. Single copy of heap and single copy of method area is shared between across multiple threads. It is only the stacks which are thread local. I mean, one separate stack is created for every thread. Okay, so that is what I meant, or that is what is the meaning when I say, or when we say they share the common address space. So if you talk in Java, all the threads belonging to the same process will share heap as well as the method area. Okay, so that is what we are entering. So let me give you the most important 2 documents and we'll start. We'll continue. So I'm sending you something because then you can keep it open and you can keep referring to it throughout the day, today, tomorrow. I'm giving you thread state transition diagram. So keep it open. So have I sent it to everyone? Yes. So download main thread and garbage collector. Of course, any threads, Rohit. Why you are talking about main and garbage collector? Any thread which you create, which will create plenty, will have its own individual stack. Okay, so you are right. The 2 stacks would be there for 2 different threads. And one more document I'm sending you. Threads API. So just download it in time. Later, you don't find it or something. So two documents you'll require is thread set transitions and the Threads API. Later, you'll require something called as blocking, unblocking triggers. I'll share that separately. So now let us discuss the most important topic in threads, which is nothing but thread state transitions. Have you received it, guys? What I'll do is I'll open it in Paint so I can keep referring to it. Okay, so you have your copy. So let's start discussing it. So title is already in front of you. All I'm discussing is various states through which a thread passes. So everything starts with does not exist. What it means is the thread is not yet created. Okay. So it could be your system thread. Which are the two system threads which JVM creates already at the launching of the JVM? Main and a garbage collector. And we are talking about, okay, let it be a system thread or let it be a user-defined thread. The life cycle is the same, so it doesn't matter. So the thread, but currently we'll talk about our own threads, user-defined threads. So threads yet do not exist. So how I take threads topic is I balance the concepts with the API. So now let us understand what are the different ways to go from does not exist to newly created thread. So I'm trying to explain what are the different ways in Java to create your own thread. Java is famous for different reasons. One of the reasons is easy support, a ready-made built-in support for multi-threading. So you will see this is what we are going to do throughout the day. So there is a thread class in java.lang package. So the easiest will be, the first example I show you with extends. So you can create a class such as new thread or my thread or your thread or whatever, extend thread, and you can create a thread out of it. Or in, multiple inheritance in Java using classes is not allowed. So what if your class is already extending from some other class? You can't extend the thread class then. So which is the more favorite, more practical, more frequently used approaches? The heart of entire multi-threading is a single interface. What is the name of the interface? java.lang.runnable. So you as a developer, you can implement runnable interface and create a thread out of it, attach a thread to that runnable task. So right now, let me just explain this. One is extends thread technique. One is implements runnable. But the disadvantage of these two techniques are programmer has to slog more. As in, you have to write a class which extends thread, implements runnable. You have to call the constructors. There is something like a start method. In short, you have to manage partly the threads. You have to wait till all the threads are over, etc. So in advanced Java, when you are sufficiently like settled, we'll be talking about a web server web container, and that time you'll see the web server uses something called as executor framework, and that time I'll show you I'll give you some overview about how this multi-threading can be managed automatically. So in today, tomorrow, and maybe some part of Monday, we are going to play with these two. This I'm going to show you just one example, but mainly we are going to write the examples on implementing runnable interface. So these are the two different, these are the two different ways. Okay. So once you use any of these approach, extends thread, implements runnable, what you get is a newly created thread. So here you have to balance it by reading also. So I have shared with you the document Threads API. So here I have mentioned everything, but instead of making you read, I'm going to, of course, you open this and I'm going to draw, or I will encourage you also draw along with me some diagrams. Diagrams means not the memory diagram, but the API related things. So everything starts with a runnable interface. Keep this document open, and parallelly, I would definitely recommend Droid. I'm going to share this anyway, you know that. So I'll give the title as regarding threads API. Because, you know, if you have a summary picture, it becomes very easy to focus or to relate to it regarding thread related APIs. So what is the starting point? Which is the first base interface where everything starts? Already mentioned. There is a java.lang.runnable interface. When I show you executor framework, there is a, in addition to runnable, there is a callable interface. The future, promise-based, everything you can understand. So here it is runnable. So what is runnable? It is an interface. Is it a functional interface, marker interface, or ordinary interface? It is a functional interface. Did it exist prior to Java 8? Of course, yes. Threads have been given to you from JDK 1. So functional interface existed even before modern Java 8. So the moment I say functional interface, what is the next question you should have? Which is that functional method, or which is that single abstract method? So that single abstract method is public void run. Keep it in points so that you don't have to read the long documents or tutorials or articles. So once you see this run method, you will see shortly that whether you use extends thread scenario or whether you use implements runnable scenario, you will end up overriding or implementing this run method. So I have to give you the meaning. What does this run method imply? This run method will contain, or should contain, I should say, should contain anything. Should contain the business logic, or you can say threads execution logic. So understand me. The threads are ultimately going to be managed by your underlying operating system, but they will have a contract between your JVM and the underlying operating system, which is totally hidden from the programmer. So whenever our thread gets a chance to execute on the CPU, whenever it gets a CPU time, which business logic, which method, which execution logic it is going to execute, whatever you have written in the run method. Okay, so this public void run method you will have to implement to supply your own business logic. So this is your first part. This is your initial block. This is your starting point kind of a thing. Okay, everyone clear? I mean, I'm not saying too many things. I'm giving you the pointed things, which only thing which you require. So functional interface, single abstract method, and the run method is nothing but containing the, will contain or should contain your execution logic. So now let us go a level deeper. So this runnable interface has been implemented by a class and none other than your thread class. So where is that thread class? Same package, java.lang.thread implements runnable. Okay. So the thread class has implemented runnable interface. Whenever you look at the implementation class, you should have the first question. Is it an abstract class or is it a concrete class? I'm giving you that answer. It is a concrete implementation class. The moment I say that, which is the method thread class must have already implemented? Easy question, nothing difficult. The run method, of course. So run method is implemented by thread class. But now you sit back and you think. See, once you start thinking rationally, everything becomes clearer, easier. So do you think, suppose my business logic, my thread execution logic is maybe take the customer orders and sort them as per the order date or dispatch them as per the order date or whatever. So this business logic, do you seriously think the thread class will guess? Can thread class understand your business logic? Of course not. So what do you think this run method is? Will it have a blank implementation logic or will it have the actual business logic? Answer is contains nothing. It's a blank. Contains blank implementation logic. There's nothing. So now the famous question. All these are very popular questions. So listen to this. So this is, of course, there are other methods. So many methods of the thread class you're going to see. So I'll talk about them separately. So now we have come to the subtype. So now I'm asking you a question. One way of creating thread is here. You can extend from, right? You know, this is an inheritance hierarchy I'm drawing as always. So you can have the arrows extends and, sorry, this is implements, this is extends, etc. So now, if I create my own subclass, okay? So example, public class. Let me give you the title first. This is my extends thread scenario. Okay. So as an example, it makes the things much better, much clearer. So suppose I write a public class, let's say my thread, you know, extends thread. So in that case, suppose if I don't override the run method, what will happen? First option, compile time error. Second option, runtime error. Third option, none of above. I got one answer from Sushant. Give me more answers. Compile time error, runtime error, or none of above. Why only two answers? Have you, okay, maybe people are drawing. I'll repeat my question. I said, if I create a subclass, extends thread, and do not override the run method, what will happen? Answer is none of above. Guys, where is your basic understanding? Here, thread class has already implemented the run method. So why should there be a compile time error? I don't understand. You will be inheriting. Will there be any runtime error? There's no chance of runtime error. But tell me, will your thread, this thread, will it be able to perform any useful business logic, or will it be like a useless, do nothing type of a thread? Useful thread or useless thread? Of course, it is a do nothing thread. Mute yourself, Shraddha. So here, what you are inheriting here is the blank implementation logic. So if you write the class as this, so no error. When I say no error, no Java compiler error, no runtime error. Whenever this thread gets a chance to run, your scheduler will swap it in. It will start executing run method, but there's no logic here. So run method will directly return. And when the run method returns, your execution logic is over without executing anything. So no error, but what you will create is, but implies whatever. I mean, you can say implies do nothing thread. Do nothing thread means it does not have or does not have any business logic. It's a popular question. Understood my statement? So what is compulsory? So even when you don't get any compiler error, this thing, now tell me. So is it compulsory? If you want to write some business logic, some thread execution logic, what is it you will have to do here? So if you want to avoid this particular do nothing business, what is it you'll have to do is override, use the correct words. So here, must override. Let me write it properly. So must override the run method, public void run method, to supply, or you can say to specify the business logic. Is the statement making sense? Read this. We started with runnable, implemented by thread, extended by my thread. So if you just don't, if you just don't provide any run method, what is it? It has got to execute nothing. So it will be like a useless thread, not doing anything. Do nothing kind of a thread. So even when you extend from thread, you will have to override the run method. Clear totally? One branch is clear. If you're drawing the things, this one, Shubham, I'm going to anyway share this. So don't worry. So all this is going to be shared. So now the next branch. Anyone wants to ask this thing, Mohammed, that why thread class implements? I already said that. Mohammed, do you think JVM is a magician which will guess your implementation logic? Simple question. No, I'm talking to Mohammed. Of course not. So since your thread class does not know which execution logic, if you are writing a multi-threaded server, you will have to handle the client request. If you are writing a server, if you are writing a multi-threaded application where you have to track the files, you will have to, the file handling logic or sorting logic or searching logic. So how can your JVM guess it? That is why when it doesn't know what to write, it keeps the method blank. As easy as that, common sense based question. Okay, so this is one approach which we will start soon. But is this the only way, or is there any other way of calling this thing, creating a thread? Answer is another way exists. So which is that another way? Do I have to have an extended thread? There is another scenario. Which is that another scenario? You can also implement from the runnable interface. So fork it now. So here, you can directly write a class which implements runnable. So now, hear my question correctly, because that will tell me whether you have understood anything about inheritance at all. So if I write, I'll mention it for you. So this is your implements runnable. Okay, so here, example. So suppose I write public class, my class, implements runnable. Okay, I have a question. So hear my question. Of course, I'll be writing things. So don't worry about that. I have a question to ask. So when you say my class my class implements runnable, can I say, or rather, can you say my class is a thread? I'll repeat the question. I said, can you say my class is a thread? It's a Boolean question, yes or no. Who said yes? Shubham, read this. Guys, is there a thread here involved? Is there a thread coming into picture? So answer is absolutely not. But can I say my class is a runnable? Of course, yes. On the other hand, if I say here my thread extends thread, can I say my thread is a thread? It's a yes or no question. Yes. So that is the major difference. When you say extends from the thread, you are already inheriting the thread class behavior. And soon you will see all you will have to do is just start a thread. But here on the other hand, when you write a class which implements runnable, all you are supplying is a runnable logic. All you are supplying is a class which represents runnable task, but you will have to use the thread class constructors to attach the thread to the runnable task. I know sounds little difficult. Once you start doing it, it is all easy. So now I'll give the name. I did not purposefully give the name because I wanted to ask you a question. So tell me, is it wise, is it smart to call this as a my thread? Should I give this name as my thread? Of course not. Here I can say my thread, new thread or whatever, but here it is not a thread. So always I have been insisting on you write the proper class names because they are you are judged by what names you give. Okay, so here all I'm saying is my runnable task. So all you are adding, whenever you are saying implement scenario, a class which implements runnable is all you are supplying is the runnable task. You will have to use the thread class constructors. I've already given you the threads API. There are some constructors which you can use in this scenario, some constructors to be used in this scenario, but that is a separate point. Now I have the same question. Listen to the question. If you create a class, my runnable task, I mean any class implements runnable. Just a second, I'm trying to fit it in one line. And if you don't implement the run method, so I'll say what will happen if you don't, if the class does not implement run method. I hope now the people will give me the correct answer. Of course, here your answer is correct. Compiler will throw you out. You will get a Java C error because compiler will say either make this class abstract, which we don't want to, because we are going to create the instance and attach it to the thread, or at least implement the run method. So let me recap what I said. Already I'm developing this diagram. So after I develop it, I'll share it with you. I'll send it to you. So which are the two different ways of creating the threads in Java? Basic ways. Tell me. You can write in short forms. Extends or implements. One is extends threads approach, other is implements runnable. So tell me about the hierarchy. Which is the root interface? Which is the interface which is the starting point of threads? Runnable. Functional or non-functional? Is it a functional interface? Yes. And I hope we have spent enough time. Anytime you have a functional interface, can it be substituted by a lambda expression? 100% yes. Can it be replaced by method reference? Maybe. If your body of the lambda expression, don't say yes blindly. It is not yes all the time. Yes, may or may not. If your lambda expression is directly calling some method of an existing method, then yes, otherwise not possible. But can I at least substitute it by the lambda expression? 100% yes. Okay, so that we will explore later. Now, which is that single abstract method is equal to functional method in that interface? Public void run. So what does, okay, let me ask you this way. Who is going to call this run method? Any idea? Programmer or JVM? Programmer is going to call this method. Completely wrong. We will never ever call the run method. That is, by the way, guys, by the way, that is also popular method, popular question. What will happen if you call run method? So let's settle a little bit in threads and I'll give it to you. I'll ask you. So forget that. JVM will call. So whenever you create a Java thread, JVM will collect all those Java threads and will give it to your this thing, underlying operating system. And whenever your thread gets a chance, it will start executing the run method logic. So tell me, whether you are using implements runnable scenario or extending thread, writing, implementing or overriding the run method, compulsory or optional, mandatory or optional? Simple question I asked you. I spent so much time. Come on. How can you say optional? If you say optional, that means you are getting a useless thread. Do you want to create useless threads or do you want to write useful threads? 100% mandatory. I think there is a problem with our English understanding. So whether you use the thread extends thread or whether you say implements, if you want to write some business logic, thread execution logic, is it compulsory to see the terms I'm using? Use the term override here. Use the term implement here. So I'm asking you, is it compulsory to override / implement the run method in order to provide the business logic? Answer is 100% yes. Everyone with me? Now, runnable interface is implemented by a thread class. Is thread class concrete or abstract? A or C? It's a concrete class. Means it has implemented the run method. Somebody was asking me why it is blank. Think a little bit before asking a question. How can Java API know what is going to be your business logic? So since they don't have any clue, what is your thread going to be? As a safe bet, as a safe option, they have kept it blank. So what will happen when you extend from the thread class and don't override the run method? Will you get any compile time error or runtime error? Answer is absolutely not. But will your thread be able to execute any business logic? Or will it be simply created and it will be dead within no time? Answer is yes. I mean, it will be just created. And since there is no run method to execute, no business logic to execute, it will simply die. You'll know this from the thread state transition. Versus when you write an implementation class, implementing runnable, and don't implement the run method. Tell me, what will you get? Compile time error, runtime error, or do nothing thread? Compile time error. Okay. So now, with this understanding, now open that Java API text file, threads API, not Java API. So I have given all these things and I have given you clearly, I know how important threads are for you. So here, if you use this extend thread scenario, you can use these two constructors. So start understanding. There is a default constructor. Soon we are going to write threads. I'm just preparing you for that. So if you use this, it will simply create a unnamed thread. I mean, you cannot supply the name. So Java will supply the name for it. And what will be the names, threads 0, threads 1, threads 2, likewise. But if you want to create your own thread, I mean, with your own name, which is the constructor you should use is the second constructor, where you can supply the name of the thread. Okay. So if you're maintaining it under one summary kind of a diagram, you can add here in this branch, which are the constructors which you can use. The thread class constructors, we are creating thread here. So you can use a default constructor, but that gives you unnamed thread. When I say unnamed, what I mean is you are not supplying the name. And there is another overloaded constructor where you can supply the thread name. So this is the one set of constructors. So this is what you can use in the extend thread scenario. So let me say this again. When your class is a subclass of a thread, your my thread is a thread, your subclass is a thread. So you don't have to do much. But whereas, understand this, because this is the scenario we are going to use everywhere practically. So here, when you are using this branch, I mean, when you are using the implement scenario, your implementation class is a thread or is not a thread? Again, I'm asking the question because so many gave me wrong answer earlier. I'll repeat the question. Is my runnable task a thread or not a thread? It is not a thread. So then what it is? It is just representing a runnable task, or it is simply encapsulating or holding your business logic in run. So here it was easy. I could just start. I just could create a thread. But here, if you want to create a thread, my runnable task is not a thread. So you will have to use the separate thread class constructors. So constructors in this branch are here. Anytime you are creating a thread, you will have to supply the runnable task. Okay. So here we did not have to supply the runnable task because my thread is a thread contains a run method. So here you will have to pass runnable instance. You can say runnable task, runnable target, runnable instance. So I hope this is the last topic in Core Java. So I hope you will not have the confusion at the last minute. So tell me, when I say runnable instance, runnable is an interface. So can interfaces be instantiated? Can you create an instance of an interface? Of course not. So anyone wants to tell me, when I say runnable instance, what does it mean? I hope I'm getting the correct answer. What does it imply? Let me see the answer. Yes, absolutely. It means instance of the class that implements runnable, or I can simply say instance of the implementation class. Okay. So when you read the API, be clear. You see in the Java docs, they say runnable target. So you have to, I'll talk in example. Thread T1, because we're going to write it in a couple of minutes. Thread T1 is equal to new thread, and here you'll have to pass instance of the class which implements runnable. So new my runnable task, and then JVM will understand it, and then we will progress through the life cycle, rest of the state transition. So if you use this, tell me, are you supplying the name of the thread, or is Java going to supply the name of the thread? Named thread or unnamed thread? Of course, JVM will supply. So there is an overloaded constructor like this here. You can, if you want to, use the runnable scenario and supply the name. Note in the sense, you don't have to literally note. You can just, if you want to write it as a summary, please go ahead. You can have a runnable task, runnable instance, and you can supply the name of the thread. So this will give you these set of constructors will take in the instance of the runnable task and it will attach it to the thread. So these are the main two approaches we are going to discuss in core Java. And like I promised, when I take you little deeper in advanced Java, the internals and all that, I'll show you the executor framework also, at least an overview. So I hope you understood which constructors to use when. Okay, so this was your basic starting point of your Threads API or thread state transition. Now let us go back to REST. So here, now you could have said, I'll talk in code, my thread T1 equal to new my thread with some name, or you could have created the instance of that implementation class and attached to thread. In either case, your new thread is created. Understanding or lost already? Is this transition clear from does not exist to new thread using extends or implements approach? Understood little bit at least? I'm not asking for 100% impossible, but at least little bit understanding. Okay, because I'm going to ask you a question now. So after your thread is created, which of the following, all these are guys popular questions. I'm trying to prepare you at different levels. So let me ask you. After this new thread has been created using those thread class instances, thread class constructors, which of the following is true or which of the following is correct? So option 1, thread class instance is created and sitting in the heap. Option 1. Option 2, a separate flow of control has started. And option 3, both of above. Option 4, none of above. You forgot the options? I'll say this. I'll say thread class instance is created and sitting happily in the heap. Option 1. Option 2, separate flow of control is created and started some execution. Option 3, both of above. Option 4, none of above. Answer is first option. Guys, here you have simply said thread T1 equal to new thread and either pass that runnable class instance or my thread or whatever. So here thread class instance is simply created and sitting in the heap. But actually a parallel flow of control, separate flow of control is created or not yet? Answer is not yet. So if you want to actually start the execution of a thread, you have a method to call. Okay, so balance between threads API and the concepts, then the whole discussion becomes interesting. Otherwise, you feel sleepy just talking theoretical. So now the first method. Read this slowly. I'll explain. So if you just create the instance of the thread using any of these scenarios, I mean, extends thread, implements runnable, has it started the execution? Is it representing a parallel flow of control yet? Answer is no. So what is it you will have to call? You will have to call, you means programmer, us. We will have to call the start method to cause the transition from new to runnable state. Okay, so come back to the diagram. So here you will have to call the start method. Let's say t dot start. T is suppose the reference. And then your thread, okay, I'm just, the whole, this combo of these two states is called as runnable. So I can say the thread enters the runnable state, or you can say here, now the parallel flow of control is created. And let me say an important statement. Guys, you were in charge, or rather you were controlling creating of a new thread and starting the thread. But all these transitions which happen after that, that is from ready to run to running, running to blocked, etc. Those are actually controlled partially by JVM and totally by underlying operating systems scheduler. So these are the only things which you can really control, creating a thread and starting. Rest of it is all controlled by or managed by JVM and the underlying operating system. Okay, so this is where you are actually created separate flow of control. Okay, so now let me focus on the next state. I already repeated it, Kunal. So here, so when you say t dot start, which of the following is true now? Thread class instance was already created, and now it is also representing a parallel flow of control. That way it is. Okay, so now here, I hope you have already some idea, but if you have no idea, I'm explaining it from the from scratch. So this state is called as ready to run. So let me ask you the meaning of it. When I say ready to run and a thread enters here, tell me, is it blocked on? Is it waiting for any event to occur? Is it blocked on sleep? Is it waiting for some input? Is it blocked at all? Tell me. When the thread enters ready to run, is it blocked or not? Some answer. Of course, it is not blocked. So it has got all the resources except the CPU time. So what is it awaiting? What is it waiting for? It is waiting for CPU slice. If it is waiting for that CPU attention, CPU time. So this is where your threads are waiting. So tell me, the moment you read the word pool, can it consist of a single ready to run thread, or can there be multiple? Single or multiple? Of course, multiple. We are going to create multiple threads in couple of minutes. So all your threads will be here if they are not blocked on any of these triggers. So they are all waiting here for CPU attention. And if you see the internal data structure, it is nothing but a queue, but it is not like an ordinary FIFO. It is a priority based queue. So this is where your threads are patiently waiting for CPU attention, for CPU time. So now tell me, what will you call this transition? From ready to run to running, is it swapping in or is it swapping out? This is context switching, typical context switching. So what will you call this arrow? Swapping in or swapping out? Of course, swapping in. So can a programmer do this swapping? Can a programmer or JVM do this swapping, or will it be done by the operating system? OS does it. So OS, the native scheduler, will pick up the highest priority thread and give it a chance. But now we come in. So when the thread gets the attention, thread gets the CPU time, where we have written the business logic, which is the method in which we have written the business logic, is run. So when the thread enters the running state, it will start executing the run method. So this is your one half of thread state transition. So take a look at it quickly. Your thread did not exist. I'm not talking about system threads. I'm talking about our threads, user-defined threads. Thread did not exist. So using one of these approaches, we will create a new thread. Just creating a new thread, just calling a thread class constructor, sufficient or insufficient? Grossly insufficient. I'm going to show you all this once we write it. So what is it you'll have to do is only the thread class instance is sitting in the heap. I mentioned all these in my what PPTs and readmes and all that. So here it is simply sitting in the heap, but the parallel flow of control has not yet started. So you will have to, programmer will have to call the start method. When I explain executor framework, none of it will be required because everything will be done by the framework itself. So going back to the point, when you call start, will your thread immediately enter the running phase? Not possible. It will be, of course, if it gets the CPU attention again, it will go immediately. But first it is stored in a ready to run pool. And it is nothing but a kind of, it is a priority queue, priority based queue. And the highest priority thread will be given a chance. And when your thread enters the running state, at that time, your supplied business logic written in a run method will start getting executed. So this is too much in detail. But if you want to look at it in a surface level, superficial level, the combination of ready to run and running is called as the runnable state. Because you cannot really pinpoint whether your thread is sitting in the ready pool or whether it is actually executing. So you can safely call it as after you call the start method, thread becomes runnable. So this is where your thread is. So now don't read this yield because I'm asking you, otherwise you'll give me wrong answer. So tell me, forget yielding. Yielding I'll explain separately. Can you tell me, can any of you tell me, when will your operating system swap out the running thread? I discussed it already. See, this is like, what do you say, little bit of prerequisite I have to, exactly. So there are two triggers. If your scheduler is a time slice based one, if the time slice of the current thread is over, the thread will be swapped out and the highest priority thread will be swapped in. Story over. If you are working in a preemptive based multitasking, if the lower priority thread is running and higher priority thread becomes ready to run, what will happen? Lower priority thread will be preempted, swapped out, and higher priority thread will be swapped in. Is everyone clear so far? Swapping in, swapping out. So now, in addition to this, can a programmer, can a Java developer request the underlying operating system to swap out the currently running thread? Answer is yes, and that is your yielding. So read it from the docs. No, you can open the docs anytime. So read this and I'll explain. Okay, so understand it. It's a static method. So how do you call it? It's a thread class API, thread.yield. So when you say thread.yield in your run method, who is requesting whom for what? The currently running thread is requesting the underlying operating system that I want to release the CPU and enter the ready state so that some other thread of an equal priority or some other thread of a lower priority might get a chance. So this is the use cases in case of, now I'll talk about the term thread starvation and all. Suppose you are having a preemptive based multitasking. The higher priority threads will keep on hogging, will keep on utilizing the CPU, and the lower priority threads may not get a chance. So in such cases, you can use yielding. This was the, exam related statement. But are we really going to, in our practical use cases, in our multi-threading applications, which we'll write in a couple of days, I mean, today, tomorrow included, are you actually going to rely on yielding? Absolutely not. So then you'll say, why you wasted our time? The exam question, popular question. Why we don't rely on yielding? Because it is just a request. Is it a request or is it an order? Is it an order to the underlying operating system? Absolutely not. So there are chances, even after saying yield, the current thread, the higher priority thread may not release the CPU. That is why any unreliable APIs, we are not going to use practically. But for understanding purpose, of course, it is required. Sorry. So that anyone asks you a question, you should know. So when you say yield, which is the possible transition which may happen, the currently running thread will end up leaving the CPU, releasing the CPU, and ends up in the ready pool. But like I said, in all the practical examples, in whatever examples we are writing, we are not going to rely on yielding because it is not a reliable API. So now we have covered the really first half. Now let me take you further. What was the job of the thread? To execute a business logic. Where are we going to write this business logic? In which method? Public void run. So now, when the run method is over, what does it mean? The execution of the thread is over and the running thread will become dead. I'll repeat the last statement again. Anytime the execution logic is over, when the run method returns, what does it mean? Thread becomes dead. Okay. And the important statement is, if you have a thread which has exhausted its, which has completed its execution, and by mistake you call a start method, what will happen? Will it restart the execution or will it throw you an exception? Answer is, dead threads cannot be restarted. You'll definitely get illegal thread state exception. So, see, the whole point of spending so much time here in the summary manner is, if you get this exception, you should know how to debug. So, when can you call a start method? If and only if your thread is in the newly created state. If the thread is already runnable or dead, and if you call a start method, which is the exception you will get, illegal thread state exception, and it will abort the invoker. Understood the statement? Yes or no? Till the does not exist today. But guys, practically speaking, if your thread gets a slice, gets a CPU time, it is, and when you have the long execution logic, it is impossible, practically impossible, that it will finish the entire execution. Because a running thread can come across so many blocking conditions. So honestly speaking, understanding these blocking conditions is basically understanding multithreading. Or I'll rephrase my statement. When you understand these blocking conditions, I'll tell you that yes, you have understood the threads properly. So let me ask you a simple question. If your running thread comes across some blocking condition, what do you think will happen? Will that block thread continue to block the CPU, or will it be swapped out and will it be sent to the block state? Will it continue to, waste CPU time? Of course, it will be swapped out to the block state. So that, guys, the whole idea about multitasking is never to keep the resources idle, so that some other ready to run thread can be swapped in and can use the CPU. Are you understanding? I'll repeat the last statement again. Anytime the running thread comes across a blocking condition, immediately scheduler will release the CPU and put it in the block state. So I see the two things. One thing is, genuinely its time slice is over or preemption can happen. So that is your running to ready transition. But here you are genuinely blocked on some condition, so it becomes running to block. So easiest trigger for blocking is sleep. So suppose, I hope you remember, there is a thread.sleep method I had shown you long back in exception handling. So let me ask you a question. Imagine you have written a run method, and in the run method, suppose you write thread.sleep, let's say 1000. The unit is milliseconds. I'll repeat my question. I'll repeat my statement. Suppose in the run method, you have written thread.sleep 1000. So what will happen first thing is the thread will release. I mean, scheduler will push it out of it and put it in the block state. So sleeping threads will be, of course, will not be using the CPU time at all. Are you understanding? And now tell me, what will happen after 1 second? Can it resume the running, or does it have to enter the ready pool and enter the competition again? How can it resume running? You know the whole business. So after the blocking condition is removed. So this is called as blocking trigger, and this is called as unblocking trigger. So what is the unblocking trigger for sleep? Sleep duration over. Later, I'll show you the interrupt signal also. But initially, sleep over. Okay. So the moment sleep duration is over, the what do you say, woken up sleep, or the thread which has woken up again has to enter the competition. And whenever it is chosen, whenever it gets the CPU time, then it will resume the run method. So sleep is the easiest one. Likewise, we are going to discuss so many blocking triggers. But the common statement is the moment blocking trigger is over, the moment blocking condition is done, a condition is removed, again it enters the ready pool, and whenever it gets chance, it resumes running. So this is your detailed look at thread state transitions. And now we are going to write a simple first example has to be simple, which will just tell you the concurrency, and then we will build upon that. Got some idea about different states and their transitions along with little bit of API? And you will get a better and better feel the moment we write more code and I show you so many things with the debugging statements. Okay, so I've shared with you the today's sequence already. So here, the first objective has to be simple. We will just create, multiple threads to test the whether it is a sequential execution or whether it is a parallel concurrent execution. In short, to test concurrency. And initially, we will go by extending thread, and then of course, we'll change it to implements enable scenario also. So this is what is our first job. But before that, I need to give you some more APIs. I need to explain some more APIs. So continue reading. So I think these two you can understand on your own. These are all the thread class methods. So set name to set the name to the thread, get name to read the name of the thread. Now there is a fifth point. So you know this. Anytime your multiple threads are sitting in the thread pool, ready pool, what will not JVM, what will your underlying operating system do is it will pick up the highest priority one. So you have to know the priority range, priority scale in Java. It is 1 to 10. These things, it is better if you see it from Java docs. So I'm just opening the API docs. And look for, you can search you can test the complete hierarchy in a minute. You can search for runnable, which is the starting point. The runnable is the interface. You'll see that it is a functional interface, can be substituted by Lambda. This annotation is the only thing which has been added from Java 8. And they give you so many good, such a good description. It can be implemented by any class whose instances have to be executed by a separate thread. And this class must define a public void run. So this is your starting point. There are sub interfaces. All these are like detailed. These are basically part of your executor framework. So implementation class which you have, simple implementation class is a thread. So thread class implements runnable, and you can see, read this carefully. Thread represents a thread of execution, and JVM allows your application to have multiple threads, multiple parallel flow of control, multiple threads of execution. The priority and all is, everything is given. So now, if you see, if you come down, they have given you examples. This is how you're going to write the threads. So if you see, yeah. So come down to static fields. So there are 3 static data members: min priority, max priority, and a normal priority. So if you check the value of a min priority, you will see the min priority is the value of 1. The default priority, if you don't set up the priority, is 5, which is what we will be using all the time. And the maximum priority is 10. So that is what I wanted to show you once from the docs. And if you want to change the priority, set the priority, the method to set the priority is the thread class API set priority, and you can supply any of these constants: min priority, max priority, or normal priority is default started. But guys, listen to the next tip. The first tip, first advice I gave you, don't use yielding. Don't rely on this yielding because it's just a request. Second programmer's tip is, don't rely on the priority scale or don't rely on priority factor while writing multi-threaded applications. Of course, there is a reason. So why I'm saying that? Because guys, this 1 to 10 is the JVM, Java range of priorities. But if you know a little bit about operating system, each and every operating system has its own range of priorities. So for example, in one operating system, this 1 to 10 can be mapped to the actual range of 1 to 100. In other operating system, it can be mapped to 1 to 5. So let me ask you a simple question. If you write a code using priority, will it give you platform specific output or platform? I mean, will you get the same output across all the platforms or different ones? Same or different? Of course, it is different. And forget the different output. The code which is using the priority may run on a particular operating system. And the moment you change the operating system and the underlying hardware, which is a platform, it may stop working. It might start give you deadlocks and all. So 2 hints, 2 suggestions is, don't rely, just understand this, but don't use the yielding and priority. I'm going to discuss so many APIs or so many techniques which will give you reliable. Reliable means which will give you a working solution. Okay, so that was your setting the priority. Now these next 2 methods are really good for debugging. So read one by one. Read the first one, current thread. So when you say, it's a static method, so either you can use import static or you can use thread.currentThread. So when you say current thread, what is it is going to return? It returns you the invoker thread reference. So guys, when you start writing multi-thread application, you easily feel lost in the control that which thread is working now or which thread is currently executing the task. So it becomes so easy when you use this API, current thread. And the last one, before writing a one-liner code, looking at time, I'm not writing threads now. We will write it after the break. But I'll write just a one-liner to explain things. Has the thread class overridden the toString method? 100% yes. Which classes method? Object classes toString method. And which is the valuable information it is going to give you? It is going to give you the name of the thread, the priority with which it is working, and the threads belong to the different thread groups. So the default thread group name is main. So you will see the name of the thread group to which it belongs. So let us write a one-liner code literally to check the details of your system thread, which is main, and then we'll stop immediately. And creating the actual multiple threads, user-defined threads, will continue after the break. So a one-liner, you don't even have to write if you don't want. I'll just create a project and keep it ready. So let me say this. (20.1), you can say class. And here, I'm going to write something. You're just going to give me the SOP, output, what will be the output. So here, and of course, we are going to continue with actual threads soon. So let me call it as threads1, a package, and a tester. So listen to the question, please. Okay, let me say give you some inputs and then I'll ask you the question. Here onwards, till you are in core Java, which is last 2-3 days, we are going to use the main thread as the parent thread to create our own child threads, to create our own user-defined child threads. Okay, so here I just want to print the main threads detail first and let you know. So I'm saying main threads details, because in the same manner I'm going to show you our own threads after the break. So if I say thread.current thread, all I want to ask you is whose details it is going to print. Is it printing your, have you yet created any child threads or user-defined threads? No. So how many threads are running in this JVM application currently? 2. So stop counting the garbage collector. Garbage collector is anyway a background thread, something called as daemon thread. So how many non-daemon threads are running in the system? Exactly 1. And if you want to debug, if you want to see the details, what is it going to print, you know? It is going to say the name of the class. Of course, it is a thread. And here it is going to say the name of the thread is main. What is the priority of the main thread? 5, the norm priority. And the name of the thread group to which it belongs, that thread group name is also main. So here, all I'm showing you is the easiest debugging statements. You just say thread.current thread and you can find out the details of any running thread. Currently, I don't have multiple threads, so I just showed you the main threads details. Using the similar API, we will take a look at competition between multiple threads and conclude more. So this is a good time to take a 1 hour break and we'll resume at 11:05. And then we will create multiple threads using extend scenario, implement scenario, and I'll take you further in the threads API. So let's have a break and resume in 1 hour's time. 11:05, please.